Okay, guys, I'm here with you today on 24.1. 24.1 is on dilations, and dilations is the only transformation that we're going to talk about in which the size of the actual figure changes. All right, and so we'll start you off. I got about four different pieces here I'm going to show you. I'm not going to use any Pearson stuff today necessarily, but it says, first of all, state whether a dilation with the given scale factor is enlargement or a reduction. Obviously, an enlargement means it gets bigger. A reduction means it gets smaller. So couple things that you want to remember. If the scale factor is equal to 1, then it stays the same size. All right. In other words, it's congruent. So that would have been regarding last chapter, really. If the scale factor is less than 1, then that means it's going to shrink. Okay. That means it shrinks or it reduces. And if the scale factor is greater than 1, that means we have an enlargement. All right, so that's some pretty basic stuff right there. And so that should allow you to move through this particular worksheet rather quickly. And we'll just share a few examples here of what's happening. So I'm going to erase this real quick. And then let's take a look at some examples. Obviously, if we take a scale factor of 2, that means it's going to be an enlargement. If I see a scale factor that's fractional, that means it's going to be a reduction. Okay, it's going to shrink. Now remember, we're going from, let's for example say we have A prime B, or I'm sorry, we have triangle ABC. So what you have to pay attention to is triangle ABC going to triangle A prime B prime C prime. If we have a scale factor of 2, then the A prime B prime C prime is bigger. If you have a scale factor of 1/8, then the A prime B prime C prime is actually smaller. All right. So again, follow those rules. I think we'll be good to go. Again, if I take a look at number 6 here, we have a scale factor that's under 1. So that means this is going to be a reduction. And on number 5, for example, you see a scale factor of 3, which means this is going to enlarge. I'm going to take a look at it from a picture perspective in a little bit here, as we see down below. And so what this basically means is, as you see, if I dilate A to B, you have to identify the type of dilation. So again, this might be a little bit tough for you guys to see in regards to where it's actually located, but it looks like to me, oh, A to B. A is this cat right here, and then B is this guy right here. So obviously, if we're going from A to B, this would be an example of a reduction. And in this particular case, just to show you something different, here is A, and B is looking like this. So this is an example of an enlargement. All right. Now, they'll do this most often around the origin or through the origin. So the one thing I want you to be paying attention to here is in terms of the points. So if we're doing the point of dilation is the origin, what you can see here is you can see you'd have to draw a ray, and it should be along that line. So if I take a look at this, you can see those points are along that line. Same thing if I go through here. I'm going to go what? Like so. That should be a line. I'm going to draw a ray from here. Notice it hits that point right there, and it hits that point right there. Okay? And so that's kind of what you need to be paying attention to as we roll through some of that stuff. That's going to be important when we get to the actual pieces there. All right? Okay, let's stop for just a second. I'll go to my next example. All right, back here on part 2, and on part 2, what we're trying to do is we're trying to actually determine what the scale factor is, okay? So again, I'm not sure if you can see this very well, so I'll copy this. This is A. And this is B. So once again, if you were to look at the lines, this is about the origin, and I know this because you can see that this point and this point are along a line. I can see that this point and this point are along the line. So there and there. I can see that this point and that point right there, along with that cat, those two are along the ray. I can see that from the origin again, these guys are along this ray. Okay, so that's something to pay attention to. Now, you only really have to do one of these. So for example, if you took a look at the distance from this line right here to this point right here, so from the origin to this point, okay, if you said that was 1, and again, I'm just using this for a reference point, you can see that if we called this 1, that we could say, hey, the distance from here to here is 3 times bigger than that, and that's what you really want to pay attention to, or 3. So I'm going to go out on a limb and say my scale factor. Now, the question is, did it shrink or did it enlarge? All right, well, if we're going to go from A to B, it actually shrunk, so the scale factor isn't 3, it's actually 1/3. All right, the reciprocal of that. Another place that you can see, and maybe an easier place you can see that you guys would believe me, if I took a look, for example, at this line right here, okay, so from origin to this point, we would say, hey, that's 2. And if I took then from the same corresponding piece from here to here, okay, how far is it? 2, 4, 6. So it's 6. And again, A is bigger than B, so it's a shrink. And so, in other words, what we'd say here is we have a 1/3 scale factor. Okay, 1/3 scale factor. And again, in essence, what we did is we went from the origin to the first point in that situation. All right, let's take a look at some scale factors. Really, all you're looking for here is 1/3. And again, to try to simplify that on this next one, let's take a look at just what I'm talking about. So in this case, A looks like it's the small guy, and B is the larger guy. All right. So what that means is we're going to have, I would use what we did a little while ago and say, hey, I know because of that it's going to be an enlargement of some sort. And so that means the scale factor is going to have to be bigger than 1. And so if the scale factor is bigger than 1, what I'm going to pay attention to is I'm going to pay attention to what's the distance from the origin to, let's say, this point right here. Okay? It looks as if the distance from those points is 2. All right? And then what's the distance from this part to this part? Well, that's obviously going to be 3. All right? And so in that case, we're going to say we have a 3-to-2 ratio. So my scale factor is either going to be 3-to-2 if we choose to go that way, or my scale factor is going to be 1.5. So in essence, what we're saying here is the black kite is 1.5 times larger than the green kite would be. We could see that in other locations as well. So if I go blue and look at those points, you would see that the distance from the origin to this point down here is 1, 2, 3, 4. All right, so that's 4. And we would see that the distance from here to here is what? 6. So it again verifies we'd have 6 to 4. Why would I put 6 over 4 instead of 4 over 6? Because you know it's an enlargement. And so therefore you're again going to get 1.5 or 1.5 is my scale factor. All right, we'll do one more of those and then we'll move on to another situation in my third thing that you're going to have to know from this. All right, so let's kick this up a little bit. Take a look at this cat right here. And so in this situation, we're looking at what? A to B. Are we going along the origin? It appears so. So it looks like if I went what? up 1 over 4 over 3, up 1 over 3, up 1 over 3, up 1 over 3. I'm right back on. That's a good way to do the rise or run idea. That tells you, yeah, it's going to go through the origin. So that's going to go through those points. Oops. Through that point, up 1 over 3, up 1 over 3, up 1 over 3, just like so. All right. So the point of dilation is 0, 0. The scale factor. So this is going to be interesting. The scale factor here is going to be what? Well, if you took a look, for example, at A, and you said, again, we're just counting to compare. So if we look at this and counted each of these angles as this, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to say that's 9. And if that's 9, let's take a look and see how big this one is. We're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. We're going from A to B, so we're going, this was going to be smaller to bigger. So that means that it's going to be an enlargement. Remember, if it's an enlargement, that means that we're going to have a scale factor that's larger than 1. So I'm going to take my 12, I'm going to put it over top of my 9. So my scale factor is going to be 4/3. All right, scale factor is going to be 4/3 in that situation. Again, if you don't trust yourself on that situation, you could go look to another piece. Obviously, we feel maybe more comfortable with a horizontal piece. And so I could look at this and say, hey, I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 there. And so here I'm at 2, 4, 6, 8, 10, 12, 14, 16 here. So once again, if I took 16 over top of 12, you can see I'm going to get simplified down to 4 over 3. All right, I'll take a break there and get to part 3 now. All right, back here on part 3, and this is the one that's probably the easiest one. We're basically going to take each of the points here on problem number 1, and the scale factor you can see is 2, so it's going to get bigger. So in essence, what we're going to do here is we're going to multiply each point by 2, all right? Each point by 2. So if I look at P and turn it into P prime, -5 times 2 is -10. -6 times 2 is -12. So that's going to be the coordinate of P prime. Q is going to be -1 times 2, which is -2. And then 2 times 2, which is going to be 4. R prime is going to be, 4 times 2, which is 8. Do that twice. And then S prime is going to be 1 times 2, which is 2. And -3 times 2, which is -6. So again, that's going to work out fairly easy for you in that situation. All right, that's probably the easiest version that you've got, other than the first one where I went enlargement or reduction. If I take a look at number 2, give you an example of a situation where maybe you have, actually let's look at number 3 where we're at a fractional situation. And so I'm at D. Okay, if I look at D and I have to multiply by a scale factor of 1/5, you can see that what I'm going to do is I'm going to take -7 times 1/5. And I'm going to get -7 times 1/5. So 7 times 1/ABC5 is, 7 over 5, -7 over 5. And then 0 times 1/5 is obviously 0. Same thing for the next, I'm going to get -7/5. I'm going to take -5 times 1/5, which should be what? -1. And then on F, I'm going to get, going to multiply -2 times 1/5, which is -2/5. And I'm going to multiply -5 times 1/5, and I'm going to get -1 again. All right? So there's your 3 points that you would come up with if I scale factored triangle DEF by a scale factor of 1/5, which obviously means I'm going to shrink it. All right, last part coming up in just a sec. Okay, I'm back. I just want to let you know that today's show is brought to you today by Texas Roadhouse. So Texas Roadhouse is today's code word. Enjoy. Looking pretty good. It's about lunchtime here as we move on. All right, so we're going to basically take a situation, and I'm just going to do problem number one here for you. My scale factor is 4/3. First thing we have to identify is we have to identify the points. So if I take a look at R is what? 9 comma 3. 9 comma 3. I've got S is negative 9 comma 3. So negative 9 comma 3. I've got P at negative 18 comma negative 3. And I've got Q at 18 comma negative 3. Okay? And so what I'm going to do is I'm going to multiply each of those points by a scale factor of 4/3. Multiply them by a scale factor of 4/3. I'll write those in blue so that you can see those a little bit better. So if I take 9, for example, times 4 ABC3, I'm going to get 12. So R prime is going to be 12, comma, 4. I'm going to have S prime is going to be, well, I already know that the Y value is going to be 4. Negative 9 times that, so that means that should be what? Negative 12, is that correct? So negative 12 comma 4. I'm going to go P, which is going to be what? Negative 18 times 4/3 is going to be negative 24. And negative 3 times 4/3 is going to be negative 1. And then my Q value is going to be, what? Positive 24. And it should be what? Positive 1? No, negative 1 again. Okay, so those should be the points that I'm going to be plotting if this holds true. Right, and again, this is going to be bigger. And so if I take a look at R prime is at 12 comma 4, that puts it right here. Negative 12 comma 4 puts it right here. I've got negative 24 comma negative 1, which puts it right here. That's not going to be right, is it? Is that going to be right? No. 4/3, 4 ABC3 times negative 3 is going to equal 4. So I screwed that up. This is going to be negative 4 here, guys. My fault. All right. So negative 4. So it's going to be 24, negative 24, negative 4, which puts it right here. And then 24 negative 4, which puts it right here. So when I draw that, again, these are going to be similar figures. We're going to find this out probably next chapter. These are going to be similar figures. Any enlargement or reduction of a figure is going to be similar to the original figure. And so you can see in that particular situation, that is the case. All right? Obviously, Pearson's going to allow you to take a look at some of their examples if you're wanting to do that. I wouldn't have a problem with that. You obviously just wouldn't catch the code word. All right? Have a great day.